So I'm going to give a talk today about a NoSQL project called Redis. Everybody else that's been up here, I think for the most part, has talked about NoSQL as kind of like big data, and my presentation is kind of go in the complete opposite direction. Redis is a lot like Memcached for people who have had any experience with that, with some interesting twists, and that's what I'm going to talk about. My system is actually small enough, not a dig on any of the other excellent storage engines we saw today. And I'm going to run it on my laptop, and I'm actually going to dare to do some live code demos and see if I can tempt the demo gods. So we'll actually get to see some code in action while I'm up here. So a little bit about myself first. My name is Kevin Smith. I own my own consulting company, Hypothetical Labs, and I make most of my living helping companies and software teams use Erlang. I've been using Erlang since about 2006. I'm the author of some screencasts for the pragmatic programmers, so you might have heard of me there. And here's some other information about me, you know, my Twitter ID, and every once in a while I write something mildly interesting on my blog. But anyway, that's who I am. Erlang brought me to Redis because one of the things I do working with clients, you know, Erlang is really good for building distributed systems. And so a part of a lot of distributed systems is some sort of caching component. So for a long time, you know, I would just reach for Memcached as like the obvious choice. Then I spent some time, I worked at Engine Yard, the Ruby on Rails hosting company, and they use Redis as a big part of a project they have called Nanite, which is this whole systems automation, systems management platform. And I got some exposure to it, and I thought, wow, that's really, really cool. And so I left Engine Yard and started up my own thing, but I remembered how cool Redis was, and I started using it on some client projects, and it's really worked out well. So Brad was kind enough to invite me down here to kind of share my experiences with you guys. So that's why I'm here. Why we're all here is to talk about NoSQL and the NoSQL movement, which I'm sure comes as no shock. And most people say, oh, it's so amazingly cool. And it really is. I mean, I've been doing development for like 15 years. And I think it was Chris that said yesterday, you know, we have had relational databases kind of jammed down our throats for years and years and years. And I'm frankly really happy that I don't have to do that anymore if I don't want to. The problem I have with NoSQL is a lot of people make the jump from it's so amazingly cool to, oh, it must be so easy. And I've worked with a couple of different teams that are trying to use systems like Couch, and they bang up against, there's a real learning curve here. I mean, it's not really that easy. There's a lot of new terminology, a lot of new technology to wrap your head around, a lot of new kind of mental and data models to get in your head and internalize before you can really be effective with it. And then on top of that, kind of to my chagrin, because I happen to like this language, some of this stuff is coded in languages which are really different from the mainstream programming languages. And so there's even an additional learning curve, especially if you're thinking about deploying this stuff into production. You know, you've got to understand how to deploy an Erlang application if you want to use Couch. So at some point, you have what, if you guys are at all Monty Python fans, and I hope at least some of you are, you have what I like to call the Gumby moment, where your brain hurts because you're totally full. And I've seen this happen with several teams. Their momentum kind of stalls because they've had to learn all this stuff. There's all these details to master. And by the time they're done with all that, they haven't quite forgotten what they set out to do initially, but it's not real clear how they're going to integrate this NoSQL thing into their application anymore. And so the whole point I want to try to get across with everyone today is that for a certain class of problems, for a certain type of application, if your data is not relational, some of these other things we've heard about today, they're not your only choice. You can go with something a whole lot simpler and get results a lot quicker. So for the purposes of my talk, that simpler thing is Redis. So what is Redis? Well, it's a key value store because I think, you know, this year everyone's writing a key value store. And it's backed by an in-memory database. Now, so this is like the first constraint of Redis. So if you're writing an application and your data set does not fit in RAM, then you really don't want to use Redis. Now, having said that, this is a screenshot I got from an ex-coworker of mine at Engine Yard, Ezra Zygmuntowicz. This is a extra large memory instance on EC2 with a fully loaded Redis store of 60 gigs. So when you say that your data set has to fit in RAM, you got to remember we kind of now live in the era of when with a few mouse clicks you can have access to a server with just tons and tons of RAM. So the other thing that Redis is Redis is really fast. So of course, the follow-on question is, how fast is it? Well, these are some benchmarks I did just on my MacBook when I was writing up these slides. Redis exposes a whole host of ops on several different data types, and we'll get to all that here in a minute. But the simplest operations it has is this get and set, where you're putting stuff in the data store or pulling it out. So I can do on my laptop in the neighborhood of about 19,000 reads a second, and I can do about 13,000 writes a second on my laptop. Redis, I heard someone call Redis kind of old school. It's all written in C. It's about 7,000 lines of C. So it's small enough that if you wanted to hack on it, you can like hold the entire design of the thing in your head. It's like knowable by one person. It's single-threaded, so you're not going to get any big performance boost running multi-core. A lot of the Redis clients, though, use consistent hashing so that you can spread your load out over several different servers, and so you can try to scale that way. And the other thing is Redis uses non-blocking I/O for all of its network stuff and disk I/O, so that's where it gets a lot of its speed. So Redis has a really simple protocol. The protocol looks a little bit like HTTP, and I'll show you some examples of it. The reason I think this is a particular strength of Redis and why I'm even bothering to point it out is I spend a lot of my time in languages that have a REPL or an interactive shell. I spend some time in Ruby. I spend a lot of time in Erlang. And so my development style is to be able to open up an interactive shell and just bang away and prototype stuff till I get something that works, and then I move it into a source file and I've got my solution. Well, with Redis, I can do something really similar in a telnet session. I can telnet into the server. The server is really forgiving on what it will accept, so if you fat finger a command or something, you can just start over and it doesn't kill your session. But you can sit there and play around with the different primitives and stuff until you find something that works for you. So it promotes this very loose and dynamic development style. It has a really easy to understand data model. There's not a lot of new stuff to learn. I would say if you're a programmer that has at least 6 months of experience, you will be intimately familiar with all of the data structures that Redis uses that you'd have to know about to use it. And like we saw, it has insanely fast performance, at least in my opinion. So what Redis doesn't have? So it doesn't have a sophisticated persistence engine. The Neo4j presentation, towards the end, he talked about, if you keep everything in memory, you're just a cache. And if you, asynchronously spill to disk, well, then you're a cache that asynchronously spills to disk. And I guess, well, that's kind of true of Redis. It does have mechanisms to write out to disk, but they're nothing fancy. It's about what you would expect. Just takes whatever's in memory, efficiently writes it out to disk, does some compaction to eliminate the dead spots, but that's about it. Nothing particularly special there. Right now, in the stable release, it doesn't have any fancy distributed capabilities. Of course, the nature of open source being what it is, I wrote this slide on Tuesday, and now this statement's actually no longer true. They're working on some quorum-based clustering capabilities for Redis, which will be coming probably in the next major release. Right now, what they have in the stable release and what I'm going to demonstrate today is just some very basic master-slave replication. And then it doesn't have any kind of fancy query engine at all. It's a key value store, and so if you know the key, you can get your values out of the store, and that's about it. So Redis is like Memcached, but it's better, and that's really the way to think about Redis. It's a key value store. It has some twists on what you do with the values that allow you to do some really interesting things with it. So the twist it has, the values can have data types, and Redis knows natively how to manipulate these data types. So there's a few. It has these kind of stringy things. Redis calls them strings, but you can do things with them so that they're not strings. You can like increment them like counters and things like that. It has lists, so you can do all the stuff you'd expect to do with the list. Push stuff on the front, pop it off, slice the list up, get the length of the list, all that kind of thing. It has sets, so you can compute the intersection of sets, the difference of a set, the union of sets. With lists and sets, too, you can do these aggregate functions and then store them off in yet another key. And it has support for these things called skip lists, which are a data structure that are a little bit like B trees, but they're coded completely differently. And this should be coming in the next major release as well. So I'm going to talk about string ops, and then I'm going to show you some code. So this is kind of the pattern that Redis follows. The operation names are all one word. Redis isn't case sensitive, so they can be upper or lower case. So you have get and set, which we've already talked about. And then it has this one called set in X, so you can set stuff in the cache if it's in the data store if it isn't already there. Get set, you can pull stuff out of the cache and set a new value. So you get the old value and kind of set the new value on your way out. Mget, multiple get, you can pull multiple things out of the data store at once. And you can, like I was saying earlier, for the string data type, you can also increment and decrement things if they're an integer. And then obviously you can remove stuff. And there's a whole bunch more. So things you can build with strings. You can build, obviously a general purpose cache. I mean, with just the capability that's right here, you've got a lot of what memcached does right now. You can also do primitive message queues and statistics. You can use the increment and decrement stuff to do kind of a rough statistics implementation. And so that's what I'm going to show you guys. Let's see. Oh, wow, that's like huge. I think I had a dream about Emacs being this large. Wow. Okay, so let's see. Show you guys incrementing and decrementing first. So this is some Ruby code. Probably not completely idiomatic Ruby code, but I spend most of my time in Erlang, so that's my excuse. There's an excellent gem for Redis called Redis RB, and so all the code I'm going to show you guys today, that's what I'm using. So I don't have a laser pointer, but I mean the code is pretty easy to follow. The first line there after the requires, I'm getting a connection to Redis. And then I'm just going to loop over this counter, and I'm going to generate some random numbers and check to see if they're even or odd. And then I'm going to increment 1 and 2 counters depending on what there is. And then at the end, I'm just going to pull those values out of the cache and print out some statistics. So it's kind of a contrived example, but I think it's enough to kind of illustrate things. So over here, I've got my Redis server running. Then here, so let's say we'll do 10,000 numbers. So it blew through those. Fancy text-based demo and all that. So it blew through 10,000 numbers and did my stats for me. Now, something that's interesting to keep in mind when we're looking at this code, and the other real power of Redis, is all of these operations are guaranteed to be atomic. So if I was running several instances of this client, it would be kind of bad form because they're all using the same key in the store, but they would not step on each other. I wouldn't have to worry about being in the middle of an increment and someone else coming in and triggering a race condition. Anytime I'm manipulating values inside Redis, that's always guaranteed to be atomic. And while that's not particularly powerful when you're working with strings, when we get to the aggregate data types in a minute, lists and sets, that allows you to do some pretty cool things. So that was that. Let's see, yeah. So the other thing you can do, and I've actually done this, not in any kind of production code, but just to prototype something to show to clients, you can even use strings as like a really basic kind of producer-consumer work queues. It certainly wouldn't be anything I would recommend you do in a production system. But again, using the atomic nature of these operations lets you do some pretty interesting things. So let's see. This is, I believe, yeah, my producer. So he's going to put a value in Redis and then wait for my consumer to pull it out. And then once that value's gone, he'll put in something else. And the consumer code is similarly quite simple. And again, I'm able to do all this because of the guaranteed atomicness of these operations. So I get that guy going. So I got my producer going, and now he's waiting on my consumer to wake up and do something. And so now I've got real basic producer and consumer in just a few lines of code. So I don't know, I might be kind of geeky, but I think that's kind of cool. So those are strings. A data type I use very often with Redis is the lists. And lists expose a lot of operations that you'd also expect to have. So there's push and pop. You can also push and pop stuff. These work on the front of the list. You can also push and pop stuff onto the end of a list. You can obviously get the length of a list and a range. Range kind of lets you do Ruby or Python style slicing on the list. So you can pull stuff, a range of values out of the middle of a list. And trim lets you drop everything off except the range, so it modifies the value that's stored in the data store. And a whole bunch more there as well. Lists I find to be like the most useful data type that Redis understands right now. Skip lists may become maybe just as useful. I can think of some interesting use cases to have a key value entry where the value is a B tree. That sounds kind of fun to play with. But you can do with lists kind of similar to what you can do with strings, but in a more robust way. So let me find. So this is producer and consumer version 2, but this is in using lists. So you can see creating my connection to Redis. I'm setting a limit on how many items I'm going to generate based on my command line arguments. And then I'm going to create this entry in the data store called work. And I'm going to start pushing values onto that list. And the pushing, remember, is guaranteed to be atomic. I'm going to increment the counter, and I'm just going to keep going. And I've got that sleep there just to make it not run quite so fast, so I have a chance to kind of do my demo magic. Then on the other side, the consumer is going to do the whole even and odd thing, but it's going to be pulling work items out of the list. Now the cool thing about this, let me get this going. So let's do 10,000 values, so this has to run for a little bit. So while this guy is running, so he's going to run. So he'll run until he runs out of items to do and then stop. But because the data is stored in Redis and because all these operations are atomic, I can keep running. I could be running multiple workers. So now I've got a single producer with possibly multiple consumers, multiple workers consuming items off the work queue. And again, not very many lines of code, and it runs pretty quickly. I mean, obviously, this isn't like Hadoop scale stuff, and I would never recommend that you'd use Redis at like Hadoop scales. But you can see for certain classes of problems, this can be kind of compelling. So let's see if my producer's still running. So that was lists. Lists are also very efficient. A common use case with memcached that tends to bite people is where you want to store a lot of values under a particular key. And it's been a little while since I've used memcached in anger, so this might have changed. But I remember getting bitten by the fact that to store multiple values under the key, you wind up doing some sort of kludge where you put delimiters in your values, and you have to pull the whole thing out to jam something on the end to write the whole thing back in again. That's a lot of network traffic in and out, a lot of memory on your client when you bring the whole value down. With Redis and lists, it becomes a really simple operation. You just push and pop stuff off the list, and the only network traffic, the only memory hit you're taking is for that particular item. So for certain kinds of data you might want to cache in the data store, lists can be pretty interesting. So things you can build with lists. So even better caches, like I just mentioned, they can be more efficient. Smarter queues, like we've seen, and job streaming. So this is kind of fun. I actually whipped this up with the help of my cohort, Sean, sitting down there in the blue shirt, looking very conservative. So let's see, where does it go? So what we cooked up was doing file streaming over Redis, which is kind of, when you look at the code, you say, okay, that's not a lot different from the producer-consumer thing. But what we're doing is we're taking this file and reading it in chunks and pushing it into Redis, and then we've got a consumer that's going to read those chunks out and write them out to a different file. So I'm going to do this whole thing over Redis, and with Redis being kind of the central point of coordination, the producer and the consumer, could be on completely different machines. And not a lot of code. So let's see. Let's see. So I've got this MP4 file. So now that entire file has been pushed into Redis. I think we can see. Yeah, so you can see I've got some more keys in my store. So I'll go over here to another window. And so, let's see. Oh, I didn't. Yeah. Stupid. That's what I get for ripping it off of YouTube. You never know if the MP4 is going to work or not. But I was able to stream the file over really easily. So that's lists. So Redis also understands sets, and you can do all the things you would expect to be able to do with sets inside Redis. So you can add, remove members. It has this thing called spop, which randomly picks a member out of the list and out of the set and gives it to you, which is nice if you need to randomly just pick a value. A whole lot better than doing, select star from foo, order by rand, blah, 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 all that craziness. You can also, if you need to, get the entire members of the set. You can compute set intersections, unions, diffs. You can do all these things atomically, and you can also do all these things and then tell Redis, don't give me the answer to those, but put those under a new key in the data store. So I have another contrived example of that, since the demo gods are smiling on me right now. We'll give that a go. So I have this, let's see, is this it? Yeah. So I have this sets demo where what I'm going to do is test kind of the variability of Ruby's random number generator. So I'm going to generate a couple sets of random numbers, and then I'm going to have Redis give me back the intersection of those two sets so I can see the duplicates. So it built the two sets, and then it found 72 duplicates between the two sets. But I've pushed all the hard work off onto the server, which lets my client be really dumb. And again, like we've seen with all the other demos, not many lines of code at all. So before I get into persistence and replication and stuff like that, are there any questions about the data structures or the operations or anything like that? No? Oh, awesome. OK. So Redis also does persistence. Like I was saying before, it's not exactly sophisticated, but it does what you need it to do. You know, sometimes you want your data to stay around longer than the Redis server is going to be up. So it has a couple of commands you can use to save things out to disk. It has these two explicit commands, save, which is like a blocking save. Redis will stop doing any work while it dumps the entire data store to disk. It also has this background save, where it will spawn off a background process to stream the data store out to disk. Natively, without any configuration changes, Redis will look to do a background save every, I believe it is, every 100 changes in like a 3-minute time period. These are all tweakable. Redis has a config file that you can run. I'm not running one for this demo, and you get some pretty sane defaults if you don't use the config file. And a key thing to remember, because this comes into play for the master-slave replication, internally, all Redis is doing is dumping to a file descriptor. And for the master-slave replication stuff, all the file descriptor is just pointing to a different location, which I think is kind of a cool thing. So replication can be configured at startup in the config file. You tell one Redis server who it's the slave of. Or you can also do it directly at runtime and tell Redis, no, you're going to be the slave of this other guy. You can also turn that on and off. So if you need to do failover or something like that, or you want to replicate and then make that guy your master while you take the master down, you can do that completely from the telnet session. So this is your typical, I think everyone's familiar with this. I won't spend any time on that slide. You can have multi-slave to single master. You can also do these nested slave things. Although in practice, I've never actually done anything more than that. One thing to keep in mind is you don't want to do this. You really do need your clients to all write to the master. Otherwise, all their rights get stomped on the next time the master replicates down to the slave. So when to use Redis? Redis is really good for caches. It's really good for compiling statistics. It's basically really good for any kind of data that's a poor fit for a relational database, but it would maybe using something bigger would be overkill. It's also good for kind of the social metadata stuff. It would be okay if you lost a few of these. If you lost a little bit of data, it would be all right. I certainly wouldn't recommend you use Redis as like your primary data store, but it can be a really nice accessory. So that's my entire presentation on Redis. I'd be happy to take any questions. This is the GitHub repo for Redis, and this is the GitHub repo for the Redis gem that I used in my demos. Any questions? Yes? This
seems pretty useful. I think what would be great, though, is if you had some kind of tree type.
Well, that's the skip list thing, which is coming in the next release.
So you can do full tree operations on that?
Yeah, that's the idea. Yeah, they're going to have that, and they're also going to have sorted sets that will be coming. Yeah, the guy Salvatore Sanfilippo, he lives down in Brazil. This is anti-res is his nick on GitHub and on Twitter. He's a madman with this code. I mean, I've seen people ask him for a feature on Twitter, and 12 hours later it's committed. I mean, the guy's like insanely responsive. I don't think he sleeps. So it's really amazing. Any other questions? Yes?
How do you know, like, how big, how many things you can push onto a list, before it'll slow down or it'll be bad?
Well, so in practice, I've put up to a few thousand things on a list. I mean, and it really depends on how big is a thing, because all this translates into memory. I will say that Salvatore, his two main design goals with Redis is performance and keeping things powerful yet uncomplicated. So I actually have up in my browser here, just to give you guys a taste. These are all the different operations Redis supports. So like, here's all the stuff for strings. There's stuff for just the key space itself. Oh, something I didn't mention, you can tell Redis to set expiry timeouts for any value, and it'll auto-expire those for you. So here's stuff for lists, for sets, for moving stuff around between databases, persistence, all that kind of stuff. So I think, to go back to answer your question, I think it depends, and I think you'd probably just have to try it out and do some benchmarking. Kind of a wimp-out answer, but I think that's probably your best bet. Any other questions? Okay, well, thank you very much.